Second part for today, we're gonna move to the concept of continuous property. So first of all, we're gonna start by making a comparison between one variable and two variable. So on the left that you see, this is the theory in one dimension. So if you wanna check the continuous property at the point x equal to a, so you're gonna use the conditions that f exists, limit f exists, and then number one and number two, they are equal to each other. This is the one that you use in calculus 1. So in calculus 2, you're gonna have the same concept as in calculus 1. If you want to check the continuous property, you have to check the three conditions. So f is continuous at the point xy equal to ab. If you want to check that f is continuous at ab, if it meets three conditions. So number one, you need f at AB exists. So you need this one, that f at the point AB exists. Number two, you need that the limit fxy xy go to AB exists. So this is the case that you have to compute limit again, because you need condition number two that the limit exists. And the last one, if number one equals to number two. If you have these three conditions, then you can conclude that the function is continuous at the point AB. This is how to check that the function is continuous at the point AB. And if it is continuous at every point in the set, we're gonna call that it is continuous on the set. So here we're gonna say f is continuous on the set d dot if f is continuous at every point xy in D. So on the box on the right, that is the definition of continuous in two dimension. But if you at one point, but if you want at on the set D, it means that you have to check for every point on the set D. Okay? Okay. So we have three examples to check the continuous property here. That will be the end of this lecture. And then next week we're gonna start differentiation, which is the part that is a little bit boring because it is not. The differentiation is boring because it's tedious, right? It's just like, you know, the formula, product rule, chain rule, quotient rule, and then you keep doing it. It's just the term getting more complicated and tedious.
How about the integration?
Integration is simple, clean, and beautiful. Yeah. So we're gonna learn about 6 hours on differentiation, or 4 hours at the most for differentiation, because this is not that hard. But integration, we're gonna spend more time on it because it's like a little bit complicated.
So it's like จบ term พอดี then we did
Yep,
exam.
yep. Alright, so we're gonna do these three examples, but before taking a look at example, all the functions that you learn in calculus 1, they are continuous. So in calculus 2, they are continuous as well. So make sure that the polynomial, trigonometric function, logarithm, exponential, they are all continuous in the domain. And if you take two functions that is continuous, you sum them, you product them, you make a quotient, so they are all continuous function. So this is fine. So the function is the regular function that you learn is always continuous, so you don't have to be worried about some there gonna be some like odd function that is not continuous later, something like the function that you have a step function. This is for sure not continuous because you can see by the picture that you have the step at the point x equal to a, for example. In two dimension you could have something like that as well, something like you have the in three dimension you have c x y, and for example if you have like any point you're gonna have the plane like on the plane c equal to 0 except the point at the center. Here you have the point on the top. Here you have everything except the origin. The origin gonna be the open circle, and at the origin at xy equal to 0 you hit the point 0, 0, 1, for example. This is the case that the function is not continuous because you have one point up from the plane, for example. But this type of function, they are super complicated to work with, so it is not continuous. We are not going to talk about it. Okay, but the function that you learn, the basic one, polynomial, trigonometric, logarithm, exponential, they are all continuous. Okay, so let's do 3 examples here. So example 11, show that the function that is given here, it is actually continuous. Okay, so you do 3 conditions. So condition number 1, you need f0, 0. It is actually 0, right? Condition number 2, you have limit fxy, xy go to 0, 0 here, and then it's gonna be limit xy go to 0, 0, 5xy square over square root x square plus y square. Now what would you do for this one? Yeah, you can do squeeze theorem because the question said that you want to show that the function is continuous. So it means number 1 and number 2, they must be equal to each other. So you expect that this is going to be 0, but how would you show it? Because it's going to be the same, right? So we're going to split 5xy to 2 pieces. 1 and 2. Again, we just learned before that we're gonna keep this thing here. What is going to use on the left you can just have x here, right? X, oh, we have square here, so we're gonna do xy. Seriously, and then this is going to be 5y. Okay, what would you do if you keep xy on the left here? So you let this thing to be your f here. This is going to be your g. Okay, and then this is different f now. This is one f, but you can change the function here to be u. Okay, change it to be u. So we use different notation. Oh, it can be f, but you have to understand that this f is this f, but this f is another one. Okay.
Just say you know.
We can say this is f1, f2, just to make sure that we use different name. Okay. So otherwise it's gonna be confusing because you use the same name. So f1 xy. Do you think it will work if you pick xy here? How can you bow it? So it's gonna be square root x square, square root y square. This is what you want to do. Does it work? And then you're gonna bow it by and you need x square plus y square, another one. but it is not a constant then, because you just cancel and then you have one left. So just x is okay then, right? Because you can cancel, just x is okay. Does it make sense? Or just y is okay. It doesn't matter which one you're gonna pick, but as long as you pick one, x or y, you're gonna bound it by one anyway, right? So you don't have to pick x and y together in this question. You can pick just x because and keep 5y squared here. The reason is because if we pick one x here, we can change one x to square root x squared, and that would be okay to cancel this thing already. Choose x is okay. Choose y is also okay, but just pick only one. Or you can pick 5x here as one, less than 5 here. That's fine as well. This is f1, sorry, f1. And then you're gonna compute limit of f2. Which is limit 5y squared 0, right? By this and this, so the limit here is actually 0, right? By this and this together with squeezing theorem. Okay, so once you have number 1 check, number 2 check, number 3, number 1 equal to number 2, right? So 3 conditions are met, so that means the function is continuous. Make sense? This is the question about the continuous function. So it's gonna be the hard one when you do the limit anyway. So but it just add 2 more conditions, which is f need to be exist at the point, and once you compute the limit and the function at the point, they must be equal to each other. All right, 2 more examples. Example 12, you discuss the continuity of the function fxy equal to this one. All right, so first of all, fxy, you plug in 0 first. So the questions ask you to discuss the continuity of the function here. So you can see that at any point x, y that is not equal to 0, 0, you're going to use the function on the top, right? So the function is always continuous. Because it is a polynomial, right? Because at x, y not equal to 0, 0, it is a polynomial here, polynomial here, polynomial here, polynomial here. You add them up, you subtract them up, and then you divided each other. So this is called rational function. So it means at the point x, y not equal to 0, 0, the function is continuous. So the only point that you have to check, we need to check at the point 0, 0. We need to check the continuity by using the checklist. Right. We need to check the continuity by using the checklist at the point 0, 0, because at 0, 0 there is no guarantee that the limit gonna be the same for the same as the value of the function. But at any point other than 0, 0, it is okay because you get rational function here. So basically you know that you only need to check at the point 0, 0 here. Alright, so sounds good. The reason why I can claim this one, it is because we talked before that polynomial, trigonometry, logarithm, rational function, they are all continuous. Okay, so first of all, let's do checklist number 1. f0, 0. This is actually 0, right? Because by the condition here, 0, 0. Number 2, limit of fxy, xy go to 0, 0. This is actually limit of xy go to 0, 0 of y to the 10 minus 2x squared over y to the 10 plus x squared. So what is the limit here? What would you do? So if you plug in 0 and 0, so you get 0 over 0. So you don't feel like, if you don't see the square root sign or you see the factoring in the proper way, you shouldn't factoring or conjugate. So you're gonna pick the line or use a squeezing theorem. Which one is better? Well, we can start picking a line first, and if it give you all 0, so you're gonna use squeezing theorem. X equal to 0, let's sign the first one. C1, you let x equal to 0. So what is the limit here? So the limit gonna be y to the 10 minus 0 over the limit on C1. So y to the 10 plus 0, right? Which is going to be the limit on C1 equal to y to the 10 over y to the 10, which is 1. And that is 1. So you found already one line that the limit is equal to 1. So C2 can be what else? Y equal to 0. And this is going to be 0 over minus 2x squared, 0 plus x squared. And limit on C2 is going to be negative 2, right? Is that right?
Yep.
You don't have to pick like x equal to y to the 5th power, but if you can, like if you want to, the harder one, because you once you pick that one, so you balance the degree at the bottom here, and then you're gonna get another different limit. Here we can conclude that the limit does not exist because 1 and negative 2, they are not equal. So the limit here does not exist. Which means that the function is not continuous. Because if it is not good for the 3 conditions, any of them, like one of them is not good, so you can conclude immediately that the function is not continuous at 0, 0. Okay. So to discuss the continuity here, it means that f, the given function f, is continuous everywhere except 0, 0. Because at the point 0, 0, it is not continuous, but at the point other than 0, 0, it is continuous. Alright, last question. Okay, let you jot down here first. So the last one for today, example 13. Should I change to something more harder? No. So the expectation that you're gonna see on the final is like maybe one easy question, one medium question, and one hard question. So by I say but what I mean by hard question is something like this or this. This is the hard one. Example 9 and 10. They're gonna be like one hard, one medium, and one simple one. Select which one?
Just the one that to jot down. This one. Just the
Example what?
No. Before the example, this one.
Here?
That's it. What is on the set D? What is set D mean?
Oh, D is just like if you feel like if D is any set. If you wanna check the continuous on the set, it means you have to check every point on that set.
Oh, got it.
Yeah.
Got it. Yes,
yeah practice Spanish อะไรไม่รู้มันอืม
อาจารย์ write the practice ค่ะ
well I will assign the exercise in the book like later this
So
week
if I can follow up the, if I can do the homework, so it's mean that I
yeah
can
yeah
survive final exam.
all right last one everyone example 13 so we want to find the value of k such that this one is continuous on r square you can see that the function is continuous everywhere already except 0 0 that you have to check right because other than 0 0 you will use this function which is already continuous because it is the rational function together with polynomial trigonometric functions so all you need is you need to check at 0 0 and find that k okay number one f00 this is what number two f00 is actually k right this is a value that we want to find and then limit fxy xy go to 0 0 x square sine xy over x square plus y square here how do you compute this one okay we're gonna pick the line first so this one you plug in 0 0 and then you get 0 over 0 so if I pick the line let's do the scratch work so what line we are going to pick x equal to 0 for example right you're gonna get 0 square times sine 0 over 0 square plus y square it is actually 0 if you pick y equal to 0 it's gonna be x square times sine 0 and then over x square plus 0 it is actually 0 as well which line are you gonna pick next y equal to x so you're gonna have x square sine x square over x square times sine oh no x square plus x square oh no x square what do you get here so you get sine x square over 2 but x go to 0 so it actually go to 0 as well
You forget about the line now.
oh yeah some of you said that say that why don't we just well if you keep picking the line and you get always get 0 it's gonna be you know the give you the idea that you should try to do squeezing theorem because you get 0 0 0 all the time
if I determine x and y for just multiple of time can I use switching theorem directly if I use it for example 2 times it get the same result
yeah I mean it depends on you you can
how many
if you can do two if you choose 2 here and then you pick 0 0 usually you should do like few more to just give you more confidence that it's actually 0
usually how many times do I need
maybe 3 or 4 or something but it depends on the question
in the exam
well if it is a squeezing theorem you don't have to show this one this is a scratch work yeah I mean like if this one is on the exam and if the answer asks you to use the squeezing theorem there's no partial credit if you use this one because you have to use squeezing theorem
you will say on the question that we will have to use
no
so we don't know it whether
yeah you don't know it you have to pick it by yourself you have to choose the method by yourself okay so next one x squared times sine xy okay everyone split it into two function what is your f1 what is your f2 So of course x square plus y square need to be here. Sine xy is the one that pretty ugly, so we're gonna pick it to g1. So here we're gonna save x square here, so which means we have f1 is equal to x square over x square plus y square. This is going to be less than x square plus y square, less than x square plus y square, which is actually 1. So this is good for the first condition. So the second condition is we need limit sine xy, xy go to 0, 0. And this is 0 because you just plug in 0 inside there, so you get sine 0. And because of this to check here, so it means that this limit go to 0, right? Because by squeezing theorem. And then by 1 and 2, to hold the continuous property, k must be 0, right? Conclusion. So to make sure f is continuous, we need k equal to 0, right? We need k equal to 0 because the first condition you get k, the second condition you get 0, so k must be 0, so the continuous property holds. Okay. Alright, and this is how you do the limit and continuity. เรียบร้อยไหมครับ Yeah, so we're gonna stop the content here, and then next week we're gonna start talking about derivative.
We assign the question that I need to practice for the final.
Yeah, we're gonna give you the practice problem for
Assign for the
we're gonna have homework for on this chapter. Yeah, we're gonna assign the sets of problem for you to do for limit and continuity.
so I just do homework.
Yeah, you do the homework, which is going to be assigned at the end of this weekend, and then we're gonna have mock exam for you, more problem for you to practice later.